In a potions lab, you have two elixirs. One is composed of 5% acromantula venom and the other 6.5% acromantula venom. You want to make 200 milliliters of elixir that's composed of 6% acromantula venom. So how many milliliters of each elixir do you need to mix together? All right, so we do want to mix together two different elixirs that are concentrated at different rates for acromantula venom. So we're wanting to take some amount of 5% acromantula venom and add that together with some amount of 6.5%, and whatever combination that will be will make it kind of land somewhere in the between. Of course, can't go lower than 5, it can't go higher than 6.5, and so we want the result to be 6%. So since 6% is a little closer to 6.5 than it is to 5, then we're going to need a little bit more milliliters of that mixture there, of course, right? So yeah, so we don't know the exact amounts of these, I guess. So if we just say that X is the number of milliliters of the 5% concentrated elixir, and then Y is the number of milliliters of the 6.5%, then we can say that the number of milliliters of the first kind plus the number of milliliters of the second kind will equal the number of milliliters total, which we do know because we do want to form 200 meters or 200 milliliters total of the resulting elixir. Now, what we also want to have happen is that 200 milliliters is going to be 6% concentrated. So actually, we would know the number of milliliters of acromantula venom in that, because if you did 6% of the 200, then that's going to result in 12 milliliters of the acromantula venom. So I think to get 12 milliliters total of the acromantula venom, then you would want to take the number of milliliters in the first one plus the number of milliliters in the second one, which if the first one's 5% composed, then it's going to be 5% of the number of milliliters that you have, which would be X, and then 6.5% of the second. And so that should all kind of add up to equal 12 there. So we now have two systems there, or two equations in the system here, one system. And then we can do some solving here. So we'll maybe proceed by, I don't know, substitution, I guess. So let's maybe isolate an x or a y in the first equation there. So if I isolate x, let's say, then x would be equal to 200 minus y. And then we can take the 200 minus y then and substitute that in for x into the other equation. So that will then yield us that 0.05 times the quantity of 200 minus y with the substitution, plus 0.065y is going to be equal to 12. And then taking that equation, then we should be able to solve for y. Yeah, so if we take 5% of 200, that is 10. And then minus 0.05y plus 0.065y is going to equal 12. So those that I just underlined there are like terms on the same side. So if we combine those together, that's going to be 1.5% of y. And then I'm going to subtract 10 from both sides as well. So that means we're going to have just 2 on the other side. And then we can divide by 1.5 on both sides there. So if we calculate what that's going to come out to be there, and we end up getting 133.3 repeating, it seems like there. So if y is going to be that value then if we plug that in right there, then we can subtract that from 200 to find x. And so if you do so, then x would have to be 66.6 repeating overall there. So that would give you a total of 200 milliliters. And then just to check that we do get 12 milliliters within that 200 to be acromantula venom, then if you check by taking 5% of your 66.6 repeating, and then you can take 6.5% of your 133.3 repeating, figure out what that comes out to be. It just comes out to be 12 milliliters of acromantula venom. And so, yeah, we're good there.